Everybody, today we will discuss the next topic, that is extrusion reaction. Extrusion reaction means it is a type of elimination reaction in which a neutral molecule or a fragment of molecule is expelled from a ring or a chain, and such type of the elimination reaction is known as extrusion reaction. Consider the example X, Y, Z. X is bonded to Y and Y is bonded to Z. And Y, the neutral molecule, is eliminated from the starting material XYZ. So for that, the bond between X and Y and Z is disconnected and the neutral molecule Y is eliminated. After the elimination, X and Z rejoined and the final product is XZ and Y. So usually the neutral molecule like nitrogen, carbon monoxide, carbon dioxide is eliminated from the starting material. So we have to study the nitrogen extrusion reaction, carbon monoxide extrusion reaction and carbon dioxide extrusion reaction. This is a very simple elimination extrusion reaction. First of all, we will discuss the extrusion of the nitrogen from some starting material like pyrazolene, pyrazoles and triazolene. First, we will discuss the nitrogen elimination, that means nitrogen extrusion, and it is otherwise known as ASA extrusion. Consider the example 1 pyrazolene, that is structure 52. If you are heating or by photochemical reaction, nitrogen is eliminated from the pyrazolene, 1 pyrazolene, and we will get neutral molecule nitrogen and cyclopropane. So in this reaction, nitrogen is extruded from the starting material pyrazolene. But the same product is obtained when the reaction is done on the starting material 2 pyrazolenes. And the reaction is taking place in the presence of either heat or in the presence of light. Next, we are moving into the next example, that is triazolene S. So in which if you are heating this triazolene, the nitrogen is eliminated and we will get aziridine as the product. And next example for the extrusion reaction, nitrogen extrusion reaction, is elimination of the nitrogen from pyrazoles. The structure 55. After the elimination of the nitrogen, we will get cyclopropenes. So these are the example of the SO extrusion or nitrogen extrusion reaction. Now we are moving into the mechanism, how it will happen. If we are doing the reaction, the first example, that is pyrazolene, after the elimination, after the extrusion reaction, we will get a cyclopropane as the product. So in this reaction, first of all, the neutral molecule nitrogen is eliminated because nitrogen gas is very much stable and nitrogen is a neutral molecule. That means nitrogen is eliminated. So we will get a free radical. Okay, you know that the free radical are highly unstable. So it attain the stability by combining the two free radicals. So it will combine together and we will get a cyclopropane ring. So similarly in the second example also, second example is this one, that is 3H pyrazole converted into cyclopropene. So in which also the nitrogen is eliminated. This is a photochemical reaction, that's why it is represented as HNu, and we will get a carbene as the intermediate. So this is the mechanism. First of all, the carbon nitrogen bond is broken and we will get a alkene, and then in the terminal position carbon is double bonded to nitrogen. After that, it is nitrogen is eliminated and we will get a resulting product as the carbene. See here, carbene is represented by the 2 dot, and 2 dot is represented by a pair of electron in the carbene. After that, carbene is a highly reactive intermediate. It will undergo the reaction and we will get a cyclopropene as the final product. Now we are moving into the next extrusion, that is the extrusion of carbon monoxide or the carbon dioxide. Some of the cyclic ketone undergo the carbon monoxide extrusion and we will get a cyclic compound as the final product. See in this example, cyclobutanone undergo elimination of the extrusion of the carbon monoxide in the presence of light and we will get substituted cyclopropane ring. Okay. Now the another example is, see this is a cyclic substituted ketone. During photochemical reaction, it will readily eliminate carbon monoxide and we will get substituted cyclobutane. So cyclobutane is highly stable because of this substitution, ethyl substitution. And here we can see that by the elimination of the carbon monoxide, we can contract the size of the ring. Okay, so the extrusion of the carbon monoxide and carbon dioxide is used, or any extrusion reaction is used to reduce the ring size. And here the certain cyclic ketone can be photolyzed and to give the ring contracted product. Next is the mechanism. See, this is the general mechanism. So in which for the extrusion of the carbon monoxide, first of all, the bond between the carbon and carbonyl group is broken and we will get the two free radical. First two radical. One, it is the terminal position which is exist in the carbonyl group, and the second one is the terminal position, CH2 radical. And after the formation of the radical, it will undergo decarbonylation. So it will extrude the carbonyl group and carbon monoxide is highly stable, and so we will get the two free radical. As in the previous case, the radical is highly unstable, so it will readily combine together and to form the cyclic product. Okay, and this mechanism is taking place in the presence of the light radiation, and this is a very famous reaction known as Norrish type 1. Next example is the extrusion of the carbon dioxide from the starting material 59, in which certain lactone means it is a cyclic ester, certain lactone extrude carbon dioxide on heating or on irradiating. Consider the example 59. It is a cyclic lactone in which the ester is the functional group. And here there is a nitrogen is also present. While we are heating, the carbon dioxide is eliminated, extruded, and we will get the final product like this. Okay. So in the last example, see the 63 last example, here also in the presence of light radiation, carbon dioxide, 2 molecule of the carbon monoxide is eliminated and we will get an alkene as the final product. These are so the extrusion reaction is a type of an elimination reaction in which neutral molecule like nitrogen, carbon monoxide, carbon dioxide, sulfur dioxide, etc. is eliminated, and this extraction reaction is mainly used for reducing the ring size. Thank you.